taking you guys along with me. Okay. Uh-oh. Uh-oh. Are you kidding me? Alright, ladies and gentlemen, while this is the most technologically advanced project that I've done so far, in my personal time and on the channel, a good brain is nothing without a good body to control. So we're going to worry about the frame now, or the control surface now, and then we'll worry about controlling it later. So we're going to start off from the bottom up. So the very base of this project is going to be a steel plate, and that steel plate is what you're going to mount to whatever you want to mount the turret to, or in my case, I'll probably end up putting a tripod on it, and it'll have the mounts for each leg. And also, on that base, we're going to be mounting our camera, but I'll get to that in a second. So we start off with the base, and then we need to worry about a way to attach the rotating top to it. And the best solution that I could find is using these, which are Lazy Susan bearings, otherwise known as bar stool bearings, but they have a high capacity for weight, not that that's a concern here. They're low friction, they have a hole in the center for putting our motor shaft, and also they have a good wide stance. Okay, from that point on, we're going to put a plate on top of that, and to sandwich this in between, and on that top plate, we're going to mount everything that needs to turn, you know, the turret, the housing, all that. That'll be controlled by a motor, and the motor will be mounted shaft down. So this is going to be put on top of that plate with the shaft of the motor going into a collar on the lower plate. So this motor is going to control the rotation, or the yaw, of our turret. Of course, we need a way to house everything. And so to save myself some time and money, I thought a good way to do that is a 30 caliber metal ammo can. They're a little hefty. You could go with plastic if you wanted to, but I like the look of metal much, much more. And again, these things are quite strong, but I guess we'll see. But if you're watching this, it clearly worked. So that'll mount to the top plate on top of this spinning platform, and here's where things get a little bit different. So this is the airsoft gun turret that I'll actually be using, and this is homemade, 3D printed obviously, but you don't have to do this. I did it for the aesthetic of the video because I wanted it to look cool. I mean, come on, it looks better in the thumbnail. But what I did is I went to the sporting goods store and I bought the cheapest electric airsoft gun that I could. I took the guts out, I modeled this case in Fusion 360, 3D printed it, and so it just, you know, looks a lot more presentable. But another option is just to use collars that fit on the shaft of your stepper motors and hot glue them or epoxy them to the side of your pre-existing airsoft gun. So you don't need to worry about any modification, you're just holding the whole gun in place to move on that motor axis. And I thought of a fun way to power this whole thing. The guys on the Hacker House YouTube channel, where I'm getting all this information and the idea from, they used a portable phone charger to power their whole setup, which is a very good idea. It's rechargeable, it's inexpensive. I just happen to have this solar-powered 4 Patriots power pack, which I really like, that I think would work perfect for this project. Because our Raspberry Pi, which is the brain of this whole outfit, uses 5 volts, well, that's the voltage of a standard cell phone charger. They generally run about 5 to 9. However, for this, we are going to use 4 AA batteries inside of a battery holder, which has yet to come in the mail. I was going to run this on 12 volts, but I found that it cycled too fast to feed the airsoft BBs into the barrel, so it didn't work. Now we have to be able to see to track, of course, and so I'll be using this Logitech C210 webcam. These things are about 50 bucks, so they are a little bit pricey, but apparently there's compatibility issues with certain webcams and our Raspberry Pi. This is a Raspberry Pi 3 Model B. At this point, it's worth noting that you don't need to know anything about code for this project. I don't know anything about code for Python, which is what these Raspberry Pis use. The only thing that you need to know about for electronics is really how to solder, because on top here we have what's called a motor control hat, which is just a board that controls our stepper motors. That's all you need to know about it. So we will need to be doing some soldering on this rail, the number 22 pin, and we'll need to put all the buses in place because they don't come pre-soldered. But this is the first small-scale soldering project I've done, and it works. So if I can do it, so can you. So all we have to do now is put the electronics inside of our ammo can, hook everything up, and hopefully it'll work. Now the program that I'm using to run this on the Raspberry Pi, it does have a manual and an automated mode. And for manual mode, you'd want the hammer to be located on the gun, pointing wherever the barrel is pointing, so obviously you can see where you're aiming. And then for automated, you just have it mounted down here so that the camera can see whatever this needs to shoot at. And so, because I plan to use this mostly in autonomous mode, I wasn't too concerned about having to mount it on the gun later on, but I did leave that open as an option. This is just screwed in place, not welded, and the way it's clipped, I could easily put a mount on the top of our gun here as long as it's not too heavy for the stepper motor to deal with. But for my purposes, I'm going with mostly automated. And I did add a little bit more of that PVC airline along here and here just to make sure that this doesn't rub with prolonged use, not that there will be much. And as you can see, I added some of that tubing around this hole as well for the exact same reason. Just want to make sure with all the movement that stuff doesn't get cut. So I'm actually going to put all of the electronics in here and then give you a quick run through so you can see everything hooked up. I think it would make a lot more sense, and frankly, it'll be a rather long process to get everything hooked up. So now it's time for nerd stuff. Ladies and gentlemen, here's where things get very, very exciting. So our turret's all done. I have the electronics in. I uploaded all of the code and all the dependencies that I was told to on that tutorial that I've guided you to in the description of this video. And I have everything functioning, which honestly, it was much easier than I thought. It just took a lot of time. In my case, I spent about 5 hours getting all the code where it needed to be and getting this functioning. So this is exactly why, by the way, that I wanted to go with Raspberry Pi instead of an Arduino system, is because I can connect to that Raspberry Pi with my laptop wirelessly through what's called a VNC, or a virtual network connection. And so I can communicate with that turret, turn it off and on, tell it what to do, and even control it, minus the live video feed. Unfortunately, I have to be connected with a cable for that. So I can be in the house, this can be anywhere I want it to be, as long as it's within range of my router, and I can turn it on and control it. Now I decided to add a cooling fan because in my testing I had some issues with a lot of heat, and of course if this box is out in the sun, you're going to have issues with heat building up. You know, it's a dark color, there's no ventilation, so what I did is I drilled a grate in the back of this ammo can, and then I put in, I believe it's an 80mm, correct me if I'm wrong, but I think it's an 80mm PC fan. It is running right now, but it is quite quiet. It's powered by this 12 volt deep cycle battery. This is an absorbed glass mat, 12 volt 5 amp hour battery. And what these are actually used for, at least where I got mine, is actually from the farm and ranch store because they work in solar powered electric fencers. So I had one of those laying around, and so that's what I'm using for the power supply, for the stepper motors, and for the fan itself. So we have our gun set up here. Sorry, we have our, I don't know what to call it, blaster set up here. We have our webcam on the front. And if we open up our ammo can, obviously you can see we have the power supply on top, which is actually charging right now, and this is only to power our Raspberry Pi. So if we open that up, you can see I have a micro USB going into the power supply for the Raspberry Pi, and then I have my stepper motors connected to the stepper motor buses on the stepper motor hat, which is connected on top of the Raspberry Pi. And then on the side, I have in the USB slot the webcam mounted here, and that's so the program can see what to shoot at. And from the GPIO pin 22 and positive and negative ground rail on the stepper motor hat, we have 3 wires running over to this relay here, which powers the Airsoft as soon as it's activated by the Raspberry Pi. And the Airsoft, because I wanted it to run on the same voltage that it did originally when it was still in its original form, I'm using a 4 AA battery pack here, and then I've got the negatives connected, and then both positives are just ran into this relay. But basically whenever the Raspberry Pi tells it to, it connects that relay and sends this thing firing. Now, to power the fan, since it is a 12 volt fan, I didn't get a 5 volt, although I should have. What I did is I actually soldered the wires coming into the stepper motor hat. I soldered those two, just a positive and negative for the fan, so it turns on as soon as I hook up the battery. And just to hopefully relieve some tension, I put these on some mounting tape up here, these stepper motor wires, there's 4 each. And on that video, it'll show you what order and which bus to put them in. It's as simple as turning screws and doing a little bit of soldering, so don't be overwhelmed. Okay, I'm back and we're functioning a lot better. I've removed a lot of the unnecessary material and it's lightened it up quite a bit. And I've also removed the Lazy Susan bearing because although that is ideal for support, it was causing a lot more drag than the motor could handle. Also, last test, that 12 volt battery was a lot lower than I thought, so I charged that back up so our stepper motors have a full 12 volts and now everything is functioning a lot more smoothly. And one thing I found that was very interesting during prior testing is that if you don't have a consistent background, when you walk by, let's say, it's pointed this way and there's a dark patch right around here. So if I were to walk over through there, it would track me, and then as soon as I passed by that and walked out of frame, it would keep shooting at that. So what you need is a consistent background, something that doesn't mimic any part of whatever you're trying to track, if that makes sense. So to start it up, we type in cd tracking-turret /. We open up that file, and then we type in python turret.py, enter. And you will have to do this every time you start it up or setting it up for any use. So we hit 1, enter, and now we calibrate this until it's right about where we want it, probably about there in line with the camera. Then we hit enter, and then we're going to move our left and right, just little motions until we get it lined up with our camera. Alright, ladies and gentlemen, I gotta wrap this up because we are quickly losing daylight, but for whatever reason you clicked on this video to learn how to build one of these, now you know how. So this was my DIY auto-tracking airsoft turret. Again, full credit to the guys over at Hacker Shack for actually doing all the work on the software and electronics of this. I just followed along with their video, which again I will link in the description of this video. Please check it out. It'll give you all the details, and even if you have no programming experience as I do, you'll be able to follow along and build one of these yourselves if you really want to. So this did take quite a bit of work. I apologize for the delay since the last video I posted, but I hope it was worth it. Okay, now to wrap things up, if you enjoyed this video as much as I enjoyed making this project, don't forget to hit that like button. And if you want to see more projects like this, please subscribe. It also helps me out extremely in the YouTube algorithm, along with the likes. And leave a comment as well if there's any questions that you have, and I'll do my best to give you an answer. And before you leave, go check out some of my other videos because you might just enjoy those too. Alright, thanks, and I'll see you in the next video. Are you kidding me? No way.